Hey, this is Scott. So, welcome back. This is going to be part of a series that I have going on, a playlist in YouTube for Bayesian statistics and decision making. I hope you're able to join me for Bayes08, where I introduce my intent for the series. We're up to Bayes08 now, so if you want to know what this is about, you can see that initial Bayes00 to see the whole playlist idea. All right, so let's get into it. Today we're talking about using Bayes' theorem. Did human error kill everyone? So what I talked about previously is the formulation of Bayes' theorem and how we can apply it. And so I went through a couple of different examples on one was a life sciences, actually detection of lung cancer, and one was did a student study prior to taking a test based upon the test scores in my class. So right here we're going to review a tragic factory accident use case scenario, and then we're going to use Bayes' theorem, apply it to improve our understanding of the human element of this particular cause of this accident. All right, this will be pretty straightforward. So here's what we have. Suppose you have, let's suppose you work for a company that makes semiconductors. And at the end of each shift, you have a maintenance crew that performs a routine maintenance check and maintenance to keep the machine working, right? You want it to keep in top condition. So to do this, the maintenance crew comes in and they open a valve on the machine, and then once the routine maintenance has been completed, the maintenance crew is supposed to close the valve. The problem is restarting the machine with the valve open can cause the machine to explode. So they're supposed to make sure that valve is closed. But company records show that the crew leaves the valve open 5% of the time. And that's determined by the arriving crew, the operating crew, in coming in the morning. So that's the scenario, that's the setup. So 2 days ago. So there are other reasons why the machine might explode other than the valve being open. But that's really not what's on everyone's mind today. 2 days ago, the operating crew finished their shift and left. And the maintenance crew arrived, performed its work, while the next operating crew stood by next to the machine, waiting to start the shift. The maintenance crew finished its work and hung around, and they were joking with the operating crew as they restarted the machine. Unfortunately, there was a huge explosion which obliterated the machine and killed every member of the maintenance and operating crews. Both crews perished. So today your boss comes in and calls you to her office and says, I want to give you a task of conducting an investigation of the tragedy. I want you to look at the records, talk to people, do whatever research you need, and I want you to write up a report to management. Tell them what you think happened. And so that's your assignment. So it turns out that there is one survivor who was standing some distance away from the machine at the time. And he tells you that he watched the operating crew start up the machine. He says that he saw that the valve was still open, but did not have time to warn the crew before the explosion. You decide to run an experiment. It turns out that from his vantage point on the day of the accident, this witness can determine whether the valve on the semiconductor machine is open or shut with a high degree of accuracy. Specifically, he will say it's correctly open 90% of the time, and he will incorrectly say it's open 10% of the time when it's actually shut. So that's the setup. So you have an expert witness 90% of the time that witness is correct. Okay, so here we go. Here's the summary of that. So, and this is all you have, because the machine itself is so badly damaged, it's really impossible to learn anything about the cause of the explosion from examining what's left of it. So what you have is the company records that show 5% of the time the operating crew report that the maintenance crew left the valve open when they finished their work, and then you have the sole surviving eyewitness that says he saw the valve open before the explosion, and you believe he's right 90% of the time. So how would you approach the problem? So if you just believe the records, then there's a 5% chance the valve was open, and possibly attributed to human error. Then alternatively, you can believe the survivor, and at that point, then there's a 90% chance the valve was open and attributed to human error. So do you believe the records, or do you believe the survivor? Which do you believe? And this is exactly where Bayes shines. So let's set this up. H is the hypothesized event the valve was open. H complement, H superscript C is the H superscript C is the hypothesized event that the valve was not open. E is the experimental event that the survivor thinks that the valve was open, and E complement, not E. E complement is the experimental event that the survivor thinks the valve is not open. So the probability of H is 5%. The probability of not H is 95%. The probability of E given H, this is the expert's reliability, that's 90%. And the probability of E and not H is 10%. So that's the setup. If we take this and we apply it to Bayes' theorem, which is this top equation right here, then what we do is, if we look at the numerator, it's 0.05 probability of E given H, right? We just said that. This is what I just went through. I just copied and pasted right here. And so it's 0.05 times 0.9, and that's 0.05. So the numerator is 0.045. The denominator is going to be that same thing. This is exactly what was on top. So that is going to be 0.045. And then plus this other thing right here. So let's calculate that out. There was a 10% chance of E given not H times probability of not H, which is 0.95 or 0.095. To do the simple math, and we get a 32% probability, and this is a probability, not like traditional statistics where we talk in terms of a repeated sampling paradigm, confidence intervals. Those are not probabilities. The beautiful thing about Bayes is this is a true mathematical probability, and it's 32%. So what this means is this is exactly where Bayes shines. The truth lies in the middle, as it often does. Was the valve open? Yes, with a 32% probability. That is your conclusion as an analyst in this scenario. So what we've done here, we applied Bayes' theorem to update the objective. Records 5% with a subjective expert account of 90%. So we've applied the experiment to the the subjective probability, and we've gotten a 32% likelihood of human error. And again, this is not confidence interval. This is real probability. All right, so if you are interested in seeing more Bayes, you can follow this playlist. This is a playlist: Bayesian statistic, causation, prediction, and prescription. I've got a lot of different videos that I'm dropping in this one. Or you check me out my YouTube channel, Scott Burke, or one of these other methods on what I've got going as far as content, books available on Amazon and otherwise. So I will see you for Bayes09. Thanks for joining.